Hello, I'm Rohan Shah with Far From Standard Tutoring. In this video, we'll learn about limits and continuity. So first of all, what is a limit? Well, in general, the limit of a function is the y value that a function pretty much approaches. That's a really informal way to think about it. Continuity, informally, is if you can draw the function without lifting up your pen or pencil. So for the first thing to remember is whenever you see something like limit as x approaches a of f of x like we have over here, just know that the answer, what that equals, is going to be a y value. That's what the limit is. It's the y value that f of x pretty much approaches as x pretty much approaches a. So what exactly does it mean when we're given, for example, that the limit as x approaches 4 in g of x is equal to 3? Well, there are only two things that we can conclude if we're just given this over here. What we can conclude is that the limit as x approaches 4 from the left of g of x equals 3, and that the limit as x approaches 4 from the right of g of x equals 3. So that's a really important thing to keep in mind. Whenever we're given that a limit exists, the only thing that we know is that the left and the right limit both exist and equal what the limit does. So that's the one thing to keep in mind. So looking at these two graphs, let's look at a couple examples of what this means. So if we're given this red function over here, and if we're asked what f of 1 is, well, f of 1 is clearly 2. F of 1.5 is clearly 2 also. Now what if we're given what is the limit as x approaches 2 of this guy? So this is the y value that the function pretty much approaches when x is 2. So now the way to analyze this always is to look at the left and the right limit. So as we look at x approaching 2 from the left, meaning we're looking at x values of 1.9, 1.999, we can see that the y value here is 2. So to answer this question, we first look at the left-sided limit, which is 2. And then we look at the right-sided limit, which is the limit as x approaches 2 from the right of f of x. And as we can see, as we're looking at x values of 2.01, 2.001, we get a y value of 1. Now, since the left and the right-handed limit are not equal to each other, we know that the limit does not exist. So the only time a limit exists is if its left and right-handed limit equal the same number. So here we can conclude that the limit as x approaches 2 of f of x does not exist. On the other hand, in the same function, f of 2, which is the exact y value of f when x is 2, as opposed to the y value that it's approaching, is actually equal to 1, because this is a filled-in circle. So f of 2 actually equals 1. So notice that the value that the function actually is doesn't always have to equal what it approaches. Here, there's no specific value that it approaches, since there are two different values from the left and the right, whereas f of 2 actually equals 1. Now let's look at another example where the situation is a little reversed. Here, if we ask ourselves what f of 3 is, we see that it doesn't exist, because at the x value of 3, there is no y value. So this, well, does not exist. But if we look at the limit as x approaches 3 of that f of x, well, again, to analyze this, what's the first thing we should jump to? The left and the right-sided limit. So first, let's look at the left-sided limit. So as x approaches 3 from the left, we're looking at x values of 2.9, 2.99. We can see that the y value is pretty much 4. If we do the same thing on the right, the limit as x approaches 3 from the right is also 4, because if we look at x values of 3.01, 3.001, the y value is pretty much 4. So since the left and right-sided limits, exist and are equal, we can conclude that the limit as x approaches 3 of f of x is indeed 4. So while in this case the value of the function doesn't exist, the limit does. And again, in this case, it was the other way around. So what exactly does it mean? What exactly does it mean when the limit and the actual value are actually equal to each other? I mean, if we look at x approaches, say, 4, whatever y value that is, that's equal to what it approaches. So the limit and the y value will actually equal. So what exactly does it mean? When exactly are they equal? And the answer is when the function is continuous. So as long as the function is continuous, if you look at here, it is continuous over here. The only places where we had that situation is where we had discontinuity. So now to more formally define continuity, instead of just drawing it without picking up your pen or pencil, we can say that a function is continuous precisely when the limit of f of x as x approaches a is indeed equal to a for all values of a. That's when a function is continuous. So now, if you're given the question, let's look at an example over here. If g of x is continuous, that implies that g of 5, as the limit of x approaches 5 from the left of g of x, that's actually equal to g of 5. And the other way around. Which of these are true? Well, if we know that g is continuous, we know that the limit actually equals the y value, and we know that if the limit actually exists, it equals to the left and the right-handed limit. So clearly, the left-sided limit will also equal to the y value if it's continuous. So if it is continuous, then it does imply this. But the other way around is not true. Just because this equals the left-sided value, what if the right-sided value doesn't equal to the y value? Then what we have is, well, the limit won't exist because the left and the right-sided ones are not equal. So the reverse is not true. And finally, continuity versus differentiation. Well, I guess for this, your tutor will explain you what differentiation is, but just know that continuity doesn't imply differentiation, but differentiation implies continuity. That means if you know that your function is differentiable at a certain point, then it's also continuous at that point. It has to be. But just because it's continuous doesn't mean that it has to be differentiable. Well, I hope you enjoyed this video, and I hope continuity and limits make a little more sense to you. Good luck.